Um, our next talk will be by Michelle Brenner, and she'll be talking about am I ready to be a senior engineer? Michelle is a senior software engineer with 16 years of experience. With a background in art school, she transitioned into tech through self-study and went on to grow into a role at Netflix. She thrives in technical leadership, solving complex challenges across diverse teams. Michelle is also a passionate community contributor, having spoken at over 35 conferences worldwide, and is currently working on an upcoming book to support others in tech. So let's welcome Michelle.
Thank you so much. So today's presentation is a brief excerpt of my favorite tips for my upcoming book, which will be available later this year, about being a senior engineer. As my gift to you for letting me talk about it, I've included early access to the first worksheet in the book, which is like a perfect follow-up to the presentation to figuring out whether you have all the skills to be a senior engineer. I will share a link in the presentation, and it will be, much later in the presentation, and this is definitely not a trick to get you to pay attention to the entire presentation. So, am I ready to be a senior engineer? As a coach and a senior engineer myself, I hear this question all the time. I get it from intermediate and mid-level engineers who are looking for a promotion, and from senior engineers who just got promoted and are panicking. In order to answer this question, we need to go back one step and answer this question. What is a senior engineer? As someone who's just written 50,000 words on the subject, I can tell you definitively that no one knows. It's true. Software engineering is just plain chaos. There's no standard rubric, and every company that has senior engineers makes up its own. It's also always changing. Things are going up and down the levels. One thing I've learned in my 16 years of engineering experience is that engineers love building stuff for other engineers. It's their favorite customer. It's the one we know best. It's why there are more AWS services than there are stars in the sky. When I started my first job as a support engineer 16 years ago, I spent an extraordinary amount of time restoring files from backup. Someone would tell me, oh, I definitely don't need this file, and then 2 days later, they would say, I need that file more than anything else. I would have to go on my computer, look up which physical tape it was in, walk downstairs to the windowless tape room, find the tape on the shelves, walk back up to the server room, and feed it into a robot so the robot could restore the file. I'd like to hope that no one is doing that anymore. Over the years, I've watched engineers' tasks like restoring files from backup move from senior to junior to completely automated. Recently, I've learned that system design, which I saw as like a solidly senior task, moving down the levels, and people telling me they're seeing them at intermediate and junior level interviews. So let's talk about our favorite topic, AI. You can't talk about the software engineer job without addressing AI. People are terrified that the job will soon disappear. They ask me, why bother working so hard to get the senior skills when the role is going to go away? The thing is, the role is always changing, but it's never going to go away completely in the near future. Let me tell you why I say that with conviction. At one time, people thought COBOL was such an easy language to learn that they'd be able to fire all the programmers and have the bankers handle all the engineering. As you know, they were completely right, and no one has any trouble with COBOL now. The same thing happened during my tenure with cloud services. They said, all these, self-service database management is so easy that we won't need to have anyone managing them at all, right? But the thing is, these innovations didn't stop us from having work. It actually just allows us to do more. I like to think of it as getting a bigger fish tank. If you think of our job as crafting code, then yes, you're definitely going to be doing less of that. But if you think of our job as solving complex technical business problems, we'll just get to solve bigger problems. I love that having cloud services gets me to have a bigger impact than I was able to have 10 years ago when I was walking tapes back and forth. I'm no longer getting tapes, but I'm still getting files for artists. They still say, I don't need this anymore, and then immediately need it. I don't know why that's not working. So finally, after interviewing engineers all over the world and bothering all of my coworkers, I narrowed down what a senior engineer is to these two things. A senior engineer understands how to build big things and is comfortable with ambiguity. The jump from mid to senior engineer includes just as many professional skills as it does technical skills. So I wanted to include both in the book and the presentation. If you haven't heard the term professional skills before, it's just another word for soft skills. I prefer the term professional skills because it sounds more, professional. Soft skills kind of feels like I'm going to be making you cookies instead of negotiating technical solutions. So let's start with building big things and what that looks like. As a senior engineer, you aren't just building features or fixing bugs. You are leading projects and building products. Instead of being given a framework, you are deciding on the framework. You're going to make these decisions when you have the least amount of information. Before you panic, one of the things to keep in mind is that whatever you decide on, a year later, all the engineers will be really mad about it. You know how it is. You know, like, you look at something and you're like, why did they do this? What is wrong with them? And the best is if they don't work there anymore, so they can't fight back. It's inevitable. With time, you will learn more and the technology will improve. Whatever you worked on, or someone else will be working on it and they'll improve it. You just need to stay flexible and be kind to yourself. Knowing that you'll always hate it a year later gives you that space to build whatever you need. Just remember that code is not being chiseled into stone. Make it work now and make it work better when you know better. For some reason, no one likes making decisions. I imagine it's something to do with the fear of getting things wrong. All I know is that most projects get to me either super vague or my first meeting is like, maybe I want this, or maybe we can do this. And my response is always something like, tell me what your actual goal is. Not what feature you want, what would make you and the people you report to happy. Are you looking for more users, less churn, more profit? Once I have that big goal, it's easier for us to narrow down the plan. I don't mind making decisions because I know the best information comes from people actually using a product. I always prefer getting a middling product out faster rather than a perfect product out later, because that technically perfect product could actually be completely wrong for the user. I have had plenty of users say they want a product, but when they finally get it, they want something completely different. And I'm like, we talked about this. And they're like, yeah, well, that was me a week ago. Now I want something else. They're not trying to sabotage me. It's just how humans work, and you just have to get used to it. My job as a senior engineer is to ask questions, find the right people, get as much context as possible, and then finally, use my best judgment. Judgment is one of those critical skills I hear all the time that AI just doesn't have. It can only come from experience. Judgment comes from understanding how people actually work versus the perfect robots we wish everyone actually was. What I was alluding to in that last story is spending time in the discovery phase of the product lifecycle. I use this super simplified version of the product lifecycle as a framework to kind of break down all the skills the engineers will need. There's discovery, MVP, growth, and maintenance. We go through each one of these phases to build products and to build a satisfying career. So let's continue with discovery. We talked about our stakeholders, and now we know what business problem we want to solve. However, engineering time is expensive. As a senior engineer, I know the next step is not to start writing tickets, but to determine whether we should buy the solution instead. My expectation is that most of you haven't got a chance to do build versus buy exercise for a new product. Most of us are working on legacy systems all the time. To help you get through it when you have it, I've developed this framework. Just ask yourself these 3 questions. Is it a common problem for many companies? Or is it a problem specific to our industry? Or is it a problem specific only to our company? What am I doing with these questions is trying to figure out how universal is this problem. Would it have been profitable if someone else had already built a company or product to solve this problem? Examples of products that are more universal are things like Microsoft Word or Google Chrome. If everyone needs it, you should probably find a way to buy it or get an open source version. That's another version of buying it. If it's a problem for only your industry, you need to do more research because this is kind of a gray area. The product could be available, but it could not be exactly what your stakeholders are looking for. Or it could be close enough that maybe you don't want to spend time building yourself. And sometimes if the vendors are motivated enough, they will make the changes that you need. You want to work on problems that your company is in the best position to solve. If you work for, say, an entertainment company, you don't want to be building payroll software. That's not your lane. This framework will help you make the decision, but whatever you decide, you will need to write a memo. More collaboration means more communicating and more memos and presentations. One of the themes in this book is how do we use AI to improve our jobs, specifically LLMs? Well, I suggest we use it to take on the tedious tasks so we can focus on the fun stuff. We want it to write our memos so we can focus on building the systems. AI is great at competitive analysis and writing memos so you can focus on making those decisions. Already starting to lose my voice. So, what decision do you make next? The next one is what you need to include in the MVP. Most people design their MVP around the simplest solution to their problem. It seems obvious. It's right there in the name. Minimum viable product. This famous painting by Pablo Picasso is often used to illustrate MVP. You don't need to draw the whole bull, just the outline, and people know what it is. However, if you only have the images on your right, how would you know whether it's worth it to create the whole picture? You can't just show someone a sketch and say, the sketch exists, therefore I should draw the whole painting, right? It's the same way you can't just get an MVP finished and then say, we got it to work, and that's the reason why we should build it for scale. I hear this all the time. You get through the MVP and immediately start building it bigger without thinking about how did that MVP actually go? That's like saying we can, so we should. Instead, you should be using the scientific method. The MVP is actually your hypothesis. And what you want to know is how do you test it? What we need is MVP metrics. Something like this. Here's some examples. User will buy this product because it solves their problem. Users will use this app because it automates a tedious problem. Or this product has a positive ROI because. I use these business metrics instead of technical metrics that you're probably more familiar with because as senior engineer, you need to make sure that what you're building can stand up to scrutiny. ROI should always be top of mind for you. Engineering salaries have been historically high, not just because we're super cool, which we are, but because we have a high return of investment. I am always thinking about both my personal ROI and the ROI for the project I'm leading. With this data, you'll be able to say, I am going to grow this product, and here is why. Or you can say, we need a different approach, and here's why. As long as you have tested your hypothesis, your MVP is a success. Congrats, you made it past the MVP. That was really fast. Now you've entered growth mode. Growth mode. You need to deal with all those features you said were out of scope for MVP. Before you do that, it's good to pause a moment and review your system design. You were moving fast, so you didn't think about these things, but now you have to scale it. Do you want to make any changes to your data model or API before backwards compatibility is a part of every single new feature? Do you want to split anything into new tables or even new services? Every new service adds overhead, but can help your core service from becoming unwieldy and ununderstandable. You want to review what other systems your team and the teams around you have built. You want to think about what do you want to copy and what do you want to avoid. Maybe you want to use a different database or try temporal for your workflows. It's easier to try out a new dependency on a new system. Just be careful. You don't want to be too unique because your team still has to support it. You don't want to be the one that takes every single page. They'll be excited to learn one or two new things because engineers are always excited to learn. That's what makes us engineers. But they'll be dismayed if you decide to introduce an entirely new stack that none of them know. It's all about balance, and we still have to do all our other work. Before we continue working through the product lifecycle, I'm going to take a quick detour and talk about system design interviews. I can't possibly teach you everything you need to know about system design interviews in 5 minutes, but I can offer some common mistakes to avoid. System design interviews are designed to test your knowledge of distributed systems and your ability to quickly build solutions. Given a bare bones product feature, can you decide on a database and an API? Can you focus on solving the main problem without getting lost in edge cases? Your first job is to start asking questions. You're allowed to ask about the assumptions you can make and the services that already exist. You can't build everything. You need to focus on the important parts. Most people frame this as fundamental and non-fundamental criteria. I like to think of it as business scope and scale. It helps me wrap my mind around it. It's what we're building and how many users does it need to support. So some people like to do the math, but when I'm interviewing, I don't really care about that. I just want to know that you know how to auto-scale and disaster recovery. I don't need to know that you can count the number of servers that you're going to need. That doesn't actually happen in real life. People often spend too much time in that beginning design phase, trying to think of every edge case before they get started. But the thing is, you can always ask more questions throughout the interview. I actually prefer it rather than us sitting in silence while you think about things. It's better for you to talk out loud so I can hear what your process is. I want to see a flowchart as soon as possible. Show me you understand the core workflow and draw some boxes. Like this. So, oh good, it looks great, really big. Here's one of the workflows from a case study that I use throughout the book for this imaginary app that I made up. Starting at the far left is the UI. I don't have it here, but sometimes a quick wireframe can help you figure out, the data that you need just by seeing some boxes for it. Then you have the security gateway and the load balancers. In the interview, you kind of just got to show they exist and that you know what they do. Then you have the API and the database, which is kind of the part you want to explore the most to show that they contain the core entities that you talked about in the design. You can see there are other services, like the notification service, that are not expanded at all. They're just kind of connected. They're black boxes. This is the notification service. That's because the question isn't about sending text messages. The question was about something else completely different. I did put event queues between my service and those other services to show how do they work together. Are they synchronous or asynchronous? It's always important that there show some separation between services. I've seen people connect multiple services to the same database. When you do that, you're actually just creating one service. I like it when people can name specific technologies, like how I put S3 there, as long as they can explain why they chose that technology and not just they heard of it, kind of like seeing a celebrity at a restaurant. Looking at this design with fresh eyes, I would make some improvements. It's expected that you will improve on your design or even start over halfway through the interview as you explore the problem or deal with all my fun follow-up questions. That's actually my favorite part of the interview, when you think you're done and I get to ask, what if this service crashes? How do you recover? What if 20 million people sign up today? What if this needs to work in Brazil and Tokyo? It's like getting to be a real-life chaos monkey. I'm going to skip a little since I'm running out of time. I want to talk about technical negotiations because that's a big part of your role as a senior engineer. When you present problems, you're going to be getting feedback, and managing that feedback isn't always easy. You need judgment to discern which feedback is useful and which you can completely discard. You also need to be able to negotiate. Many technical problems don't have a single best solution. Instead, they have multiple equally pretty good solutions. If someone suggests an equally good solution, you shouldn't dismiss it just because it wasn't the idea that you had. You might not even realize that's why you're doing it, but that's what we do as humans. We like our ideas more than other people's ideas. You really want to think about it. What are the pros and cons of these different solutions? It can be useful to use these solutions instead of yours because it shows that you're a team player, that you listen to people. When you listen to people, they will listen to you. It's all about that negotiation. People won't want to give you feedback if you never use it. If there are really big downsides, of course, think about it and don't use it. But you want to pick and choose your battles for the important decisions. One trap people fall into during these meetings is bike shedding. They find an easy problem, then spend all their time trying to decide to have strong opinions about it because they don't want to address the actual difficult problem. Try to quickly get everyone's opinion on what color to paint the shed and just move on. So once you have your architecture, time to build your roadmap. Sometimes you'll have a product manager, sometimes your engineering manager will do it, or sometimes you'll be in charge of it. The thing I've learned about this senior engineering role from different people is that it's always different. You know, the role could be just technical, or it could be a lot of product management or a lot of team leadership. It's kind of good to have all these skills in your back pocket, so whatever your team is doing, you can take your basics and work on it and help your team. So if you are in charge of the roadmap, or at least helping with it, you want to break it down into these manageable milestones. I like to use demos to mark each milestone, even if it's a demo that I never show outside users, just my team, so I can show that things are starting to work, that they show some progress. It also keeps the focus on the user. Sometimes you can get lost in the technical problem and forget, what did the user actually need? It can also be used to reevaluate the priority and current design. Are we going in the right direction? And then you want to break it into smaller tickets, and that's when most people will do estimates. I've actually stopped doing estimates completely. They are not helpful when you're doing a project with a lot of unknown unknowns. It's just too hard to guess. The only reason you need it is because someone's probably asking you, when is this going to get done? Whatever they ask me, I just think of the biggest number I can think of and multiply it by 3. This is going to get done in 3 months. You know, it might get done in a month, it might get done in 2 weeks, but I won't know really until I start working on it and can have that, discovery phase of, oh, this is how difficult this is going to be, or, oh, this is actually not going to be that hard. And I just want to let you know that roadmaps are obviously helpful, but be careful about doing too long of a roadmap, because then you're actually doing waterfall. And most of us aren't doing like pure agile, but we definitely don't want to be doing waterfall. Just remember that any product decision can be changed, just like code is changed. All right, I'm going to jump ahead a little bit and talk about on-call rotations. They're one of the most stressful activities we do as engineers. And yet, support always seems to be the last ticket in the sprint. It's up to you as the leader and the senior engineer to push for it. You might need to repeat yourself or be more forceful than you're used to being. You're used to taking things in and doing them. You might not be used to telling people, we have to do this. Features are easy to sell because the ROI is obvious. With support and security and tickets like that, it's all about selling the cost of what could happen. So if we don't do this, our engineers will spend all their time in support or firefighting instead of working on cool new things. Observability is a huge topic, but these are a few steps to get you most of the way. Whenever I'm on call, the first thing that I check on my triage list is, has there been a recent change? How fast can I roll back whatever service I think it is? Your deployment system wants to be one of the most important things you start at, because if you can't roll back, you're going to be in trouble. And the longer your incident goes on, the angrier people will get. And the next thing you want to do is get as much logs as possible. It's always better to start with more and then, filter them out or roll back instead of having to do a deployment just because you don't know what's happening in that section of the code. And when you have multiple systems, which you'll have in a big product, you want to make sure that you have something that you can trace the user path through each of the systems and not just each system focused on its own thing. Just some ID or username will help. And the best thing you want to have in an ideal world is a bunch of automated tests for every deploy. But that can take a long time. I actually always start with manual tests so I can focus on the customer experience. Can I get the thing done that they want to get done? AI is super useful for building tests. I'm sure you've done it and you've built 100 unit tests. It is much less useful at looking at 5 different systems and building an integration test that can go through each one. So if you have to start with manual tests, and then move on to automated when you can. Runbooks are also a thing that comes up all the time, but I found they quickly get out of date. Try to make sure your errors and your alerts actually tell you what you need to do, as opposed to just telling you there's a problem. Even if they can't tell you exactly, they can at least tell you where in the code it is. So I'm going to skip ahead because I only have 1 minute left, and I really would love you to do this. By show of hands, how many of you have felt they gained something valuable today? Awesome. Okay, the best way you can give back to me is to take less than 2 minutes and fill out a very short survey. And this will be, the end of the presentation because I didn't talk fast enough, even though you probably thought I talked so fast you couldn't hear half the things I said. So all you have to do is take out your phone, open your camera app, and scan the QR code, or put in, this code when you go to that website. I want to know what you liked about the presentation so I can do more of it, and what you disliked so I can do less of it. And as a bonus, that gift I was talking about, that worksheet, you get that worksheet by filling out the survey. So just take a minute, scan that code, and give me feedback. It feels like most of you have gotten it, so I'll just run to the last slide just so you can see it, and then we'll kind of have to wrap up. Let's see. So just quick reminder, here's all the skills we talked about today, and they'll all be on that worksheet that you'll get from the survey. And then finally, because I can't help but promote myself, if you have more questions, you can find me in the hallway or on LinkedIn. I am happy to chat. In fact, I love chatting about this topic because I want to make sure the book can be as best as it can be. Obviously, we couldn't get through everything in a short time, so if you enjoyed this, here's the pre-order for the book. And after the book comes out, I'll be working on building a community so we can all help each other level up and have the best careers that we can have. Thank you for having me.